Hello everyone. Today we are going to see the experiment in a data structure implementation of singly linked list. So our aim is to create a singly linked list and implement the following functions listed below. First I'm inserting a data to front of the list, and then I'm inserting data to rear of the list. Then I'm inserting a data in between a list. So this is called insertion function. Then second function I'm doing here is deletion. I can delete any data from the list. And third one is I'm searching a data from the list. And fourth one is displaying the content of the list. So four major functions I have to do here. So let's go to the program. This is the program. First we are creating a class node. Then I'm initializing it and I'm giving the parameters self data. So self dot item I give data and self dot next equal to none. Instead of null, I given none. We don't know the elements, so I'm given none here. Then first you have created node, then I'm created linked list. Also I'm initializing it. I'm giving the parameter self. Then again I'm giving head as none because we don't know the value of head. So I'm giving none instead of giving null. So here comes the main function. We are going to insert element the front of the node, I mean front of the list. So I'm defining the insert front function and two parameters self comma data. So now I want a new node. So I'm getting new node, that is node data. Then new node I'm giving to head because we all know that in a linked list there will be always a head at the front of the node. So I'm assigning new node to self head. So finally in head the new node is assigned. Head always comes in front. So self head is equal to new underscore node. It's a variable name, you can give anything. So insert front is over. Then we are coming to insert rear. Insert rear is nothing but in a node if I have three values such as 5, 5, 10, 15. The fourth value I have to insert 20. That is the rear. So I am taking the rear value as 20. It travels from the first element, that is 5, 10, 15. Then at last it inserts the 20th value. So it travels in rear operation. So if self head is none, we cannot do anything. We cannot insert element because if we insert the element also, it's considered as front and both rear. So we are going to return if while n next is none, not none, n is equal to n is assigned to n dot next, that is n dot next is equal to new underscore node. Yeah, since it's showing n is 5 and n1 is node 2 is 10, node 3 is 15. Finally, node 4 will be become 20. So last value is none, null value. We all know that. While we are inserting an element to null, the null goes under reference, and finally the fourth value has the null, which we are going, the fourth values we are going to insert the rear value. So it insert rear function is nothing but traversing through each node and going to last node and assigning null value as a reference value. So we get the insert rear. Insert after item is done by using indexing. For example, 5, 10, 15 are there. After 10, I want to add 12. So I use this insert after item function to add the element 12 after 10. So I'm assigning n equal to self. Okay, you all know n is equal to self dot head. If n is not none, n item is equal to x. We want to know x, the element we are going to add in between two elements. So if n is none, print item not in list. Else, same we used here, new node, same we are using here also, so that we can add a data to the element of a next data. So three insertion function are over, adding element front, adding element rear, adding element after item. So we are coming to delete. Delete and search operation are similar. If self head is none, the list has no item to read. Yeah, if list is if in a list if there are no elements, we cannot delete anything. Same if a element has x, that is if an element have an element. I mean if a list has an element, it returns a value, that is if while n dot next is not none, n is equal to next item equal to x, that is the element to be deleted. So n is assigned to n dot next. If n is not none, item not found in list. If we type an element which is not in the list, then it prints item not found in list. Otherwise, n dot next is equal to n dot next, that is they're giving a variable. So we are giving a parameter so that it deletes the operation used here. So delete is over, then search we are coming. Search is similar to delete only. Only difference we are changing those parameters. Like I'm using a count function so that if we give the position of the index, it search the elements and shows. So if we don't enter the element which is not in the list, then it shows list as not no element. I mean, the value is not found. It like it shows search element item. Then we are coming to display. Display. We are simply giving the main function self.head. It displays all the elements in the node using the symbol arrow symbol. Then also next item it prints. So every item prints. And finally, if there are no elements, it prints none. So now I'm creating a linked list to execute the program, menu-driven program to get the choice from the user and execute those functions. So I'm giving data tree, insert data front, insert data record position, that is after the data, delete data, search data, and display data. So now I am giving choice 1, choice 2, choice 3, choice 4, choice 5. We all know what is menu-driven program, and I'm running this program asking my choice. So I'm giving choice. I want to enter an element at front. I'm giving 10 for example. Then I'm entering an element to rear. I'm giving 2 in. I'm giving. Now we all know that there are two elements 10 and 15, 10 to front and 15 to rear. Now I want to add an element in between 10 and 15, that is data after data. So I'm giving my choices 3. Is asking enter the data after which the data to be added. So I'm giving 10. After 10 only I want the data. Now I'm giving 13. I want the number 13. Now let's display. I mean, let's see the data we entered, whether it's correct or not. I'm giving 6. So the values are being displayed 10, 13, 15. Final value is null as said to be. Then I'm giving choices 4 to delete the data. So I'm giving 4. Then I want to delete 10. No, sorry. If I give delete data and I'm giving a value, such as any value you can give, so I'm giving 10, 13, it can be anything. Then again I'm displaying the value, whether the being deleted or not. So 10 is being deleted. And again I'm giving, now I'm giving search. Let's give a number which is not in the list. I'm giving 2. Yeah, there will be no item, so it don't shows anything. Now play the final values. Same thing. Now let's delete these both values and see what is happening. So I'm giving delete data 13, and again I'm giving delete data, which is one option, fourth option. Then I'm giving 15. Then I'm going to display the values are none. There are no values in the program. So this is how the insertion, deletion, and search operation works at data structure and algorithm. I'm giving